Module 4, Section 1 deals with powers and exponents. This is the first chapter we're going to do that is exclusively for the accelerated math program, so it ought to be fun to see where it takes us today. The course objective: students will write and evaluate expressions involving powers and exponents, and the suggested pacing says we should knock this out in one lesson, so hopefully we'll be able to get this done pretty quick in one video too. Data storage capacity is measured in bytes and is based off of powers of 2. A standard scientific meaning for the prefix mega and giga are 1 million and 1 billion. So a megabyte is 1 million bytes and a gigabyte is 1 billion bytes. And a byte, guys, is simply a 1 or a 0, an on or an off switch is all that each byte is, and the combinations of all those 1s and 0s make up everything we see on the computers, including my smiling face at you. In computer science, a megabyte is equal to 2 to the 20 bytes. Gigabyte is equal to 2 to the 30th power bytes. Why is it useful to write these numbers as exponents? Well, do you really want to have that many zeros and have to write that many zeros? I know I wouldn't want to. Our inquiry question wants to know how you can write repeated multiplication in a different way. Well, that is going to be using exponents, and we're going to see that here in just a minute. Emily decided to start saving money by putting a penny in her piggy bank, then double the amount she saves each week. She wants to determine how long it will take her to save enough money to buy a pair of shoes that cost $80. It would be a lot quicker than you think it is, because when you're doubling every day, it gets to be pretty large pretty darn quick. Now, Emily is doubling the amount she saves each week and then adds this to her total savings. We're going to take and complete the table below to find the first two columns that have been completed for us. So, for example, she started with 1 cent and 1 cent. The next week she did 2 cents, and then from there that 2 plus 1 added to 3. So she can double that. That would be 4 cents. Double 4 cents would be 8 cents. Double 8 cents is going to be 16. Double 16, well, that's going to give you 32. And when you do the math, 4 plus 3, that's going to give us 7. 8 plus 7, that's going to give her 15. 16 plus 15 is going to give her 31. And 31 plus 32, that is going to give her 63. Check your answers. Everything checks. You can see how quickly that amount is going to add up there. So do you think Emily's close to her goal here in week 5? She's only got 63 cents. She's got to get to $80. How much longer do you think it's going to take her? So we have our table listed here, and they have some questions for us. First, what multiplication expression could represent the weekly savings for 3 weeks, and then 5 weeks, and then 10 weeks? And it says, study the table. How could you use patterns to find the total savings for any week? And then in that week, without having to use addition, and then again, in what week will Emily reach a goal and have a total savings of $80? How did you determine this? Well, we're not going to determine that. We got more better things to do than dig through that. I'd much rather see what they have to say. Now, all that said, I am seeing some pretty good patterns here. Of course, obviously the weekly savings double each week. But the other one, the total savings, if you were to take and look, when you went from 1 to 3, what you did is you did 2 times 1 plus 1, and that gave you 3. 3 to 7 is 2 times 3 is 6, plus 1 is 7. 2 times 7 plus 1 is 15. 2 times 15 plus 1 is 31. And 2 times 31 plus 1 is going to be 63. A product of repeated factors can be expressed as a power, and that is using an exponent and a base. We're going to watch this animation to learn a little bit more about powers. Let me zoom out just a little, and that should work right about there.
To write the product of the repeated factor 3 as a power, express the number of times 3 is used as a factor as an exponent. The expression written as a power is 3 to the fourth power, or 3 to the fourth. The base is the common factor that is being multiplied. The exponent tells how many times the base is used as a factor. This expression has two different bases. To write the expression using exponents, express the number of times the base 2 is used as a factor as 2 to the fourth power. Then express the number of times the base -4 is used as a factor as -4 to the third power. The expression written as a power is 2 to the fourth power times -4 to the third power.
And notice they did not even solve the problem. They just said to rewrite it using exponents. So when they were done, that's 2 to the fourth times -4 cubed. That's all they had to do. They were done at that point. So let's take a look and see if we can identify what the parts are. The base is going to be the 5. That's going to be the large number that we're multiplying. The exponent, that is going to be the 3. The entire thing is called the power. When you put it all together, that whole unit is being called a power. Of course, we can check our answer, and of course, we got the right answer. Now we're going to move through some slides to see how powers are actually going to be read. 3 to the first power, that is just going to end up being 3. We could also refer to it as 3 to the first power. 3 to the second power, where you're using 2 3's, we call it 3 squared. 3 to the third power, where you're multiplying 3 3's, is going to be 3 cubed. But after that, they really kind of don't have any cutesy names anymore. 3 to the fourth power, yeah, that's just 3 to the fourth. Nothing exciting there. And I'm thinking 3 to the fifth power. Oh, nope, they went on to 3 to the nth power. Is just going to be known as 3 to the nth, where n represents any number of times you're actually multiplying it by itself. Let's say you were tasked to write this expression using exponents. It's really extremely easy to do. How many times do you see a -2 in there? 3. How many times do you see a 3/4 in there? 4. I mean, it's really that easy, guys. So from there, we're going to take and move through the process where they say that -3 is used as a base 3 times. 3/4 is used as a base 4 times. So the exponents are going to be 3 and 4. And you can actually see that right here in the final answer, -3 squared. Make that a little bit bigger maybe. Let's see if I can zoom in a little bit. -3 cubed times 3/4 to the fourth power. Notice though that on the 3/4 you have it in parentheses because you're squaring both the, raising to the fourth power both the 3 and the 4. If you didn't have in parentheses, you would be only raising the number it was by, which would in this case be the 3. Likewise here, we are cubing the entire -2. If the negative sign was not in the parentheses, the only thing that would be being cubed is the 2. So what is the advantage of writing things to powers anyhow? Well, let's go back and look at it. What is easier to write? All of this or this little bit here? It's just easier to write. Nothing more, nothing less. Now it's going to be time for you guys to do one of these on your own. I'm pretty sure you're going to knock it out really, really quick. Go ahead and solve the problem, which is right there. Did you get it done? Let me show you what I'm going to do. I've got 3/4 here, so that one, get my exponent option here, which is right there. So that is going to end up being 4 to the third power, and then I'm going to multiply that times, in parentheses, a -9, and how many -9s are there? Well, that's going to end up being, and I think I may have screwed up there. I think I'm going to have to back out. Hold on. No, I didn't screw up. I was able to go ahead and raise it. There was 5 9s there, so it's going to be to the fifth power. I'm going to hit accept, And I'm going to hit check. And what do you know? The computer even liked the way I typed it. Beautiful job. But what if we wanted to write algebraic products as powers? In other words, letters. Well, I'm sitting here looking at that thing. I see 2 A's and I see 3 B's. I also know that the commutative property of multiplication says order doesn't matter when multiplying. So I can move those around any way I want to as long as we have straight multiplication going on there. And that's exactly what your textbook did. You can see here, see if I can zoom in a little bit for you. They took the A's and they put them in the front, they put the B's and they put them in the back, and that's the standard way we do it. We're going to do it in alphabetical order. There was 2 A's, so it's A squared times 3 B's, which is going to be B cubed, so the answer is going to be, well, I'm not going to retype it because they kind of gave it to us right there. A little bit of reiteration, that commutative property, that's a really important property that we're going to be using. That allows us to take and rearrange the order of things that are just multiplied or of things that are just added. You have the commutative property of addition and the commutative property of multiplication. Now it's going to be your turn to do the same thing, only this time I think you're probably going to be doing it with variables instead of with actual numbers, just like our last example was. So here's your problem. You're going to need to start off with your commutative property to rearrange things. Make sure you're showing me good supporting work just like they did in their example, because if you're not, I can't give you credit for doing it. Remember, just giving me answers is just earning a 0 on your homework and your test. So the first thing I'm going to use is my commutative property, and I'm going to put them in alphabetical order. So I've got 3 x's here. Nope, I've got 4 x's here. And I've got 3 y's here. So now I have rearranged things in the alphabetical order, grouping my like terms. And then I'm going to go from there. I had 4 x's, so that is x to the 4th, times I have 3 y's, that's y cubed, and that's all you have to do for that problem. Let me jump back over here. We have x to the 4th, y cubed, that's going to be answer C. Check your answer. It's too simple, too simple. Now earlier I touched on the concept of the negative base, where we have the negative base in parentheses. For expressions that contain negative signs and or parentheses, the inclusion and placement of the parentheses can result into distinctly different expressions that have different values. For example, do you think that negative a in parentheses raised to the b power and negative a to the b power have the same value? The answer is no. We're going to select some words and buttons and whatnot down here and compare and contrast. So let's see how this goes. First off, in words, we can say that here you had negative a raised to the b power means that negative a only was raised to the b power. And negative a with no parentheses raised to the b power is going to be the opposite of a to the b. It means the opposite of a to the b. Now, what that means is it's just raise a to the b power. That way they said it doesn't make a whole lot of sense. But here you can really visualize it. So a, negative a to the b power, you can see all of these negative a's, b times. But on the other one, the negative sign is outside of the parentheses that they're grouping all their a's with, and the a's are raised to the b. We're not raising the negative sign to the b power, only the a's themselves, and in numbers you can see how it would look there. So say if we raise it to the 4th, negative 3 in parentheses to the 4th power, yes, that equals a positive 81. But negative 3 without parentheses raised to the 4th power, only the 3's are going to be raised to the 4th power. The negative sign's outside the parentheses, that means the final answer is going to be positive 81. Two very distinctly different answers, just depending upon where the parentheses are placed. And now we're going to pick up a new vocabulary word, and that is evaluate. And evaluate means to write the power as a product and then multiply. To evaluate expression would be to write the power as a product and then multiply. So that's a new vocabulary term we're picking up here as well. And then when evaluating expressions with powers or more than one operation, it's important to remember to use your order of operations. Remember, that's PEMDAS. The first one, P, simplify all expressions inside grouping symbols. We call those parentheses, or things separated by the division bar. Next, E, exponents, evaluate all powers or evaluate all exponents. And then my dear, multiply and divide from left to right. And then Aunt Sally, add and subtract from left to right. Always remember to use your order of operations as you're going through these problems. Now I think that's probably going to be a really good spot to stop. When we come back, we're going to work on evaluating some numerical expressions that involve exponents. Be sure to come back and watch part 2 of this video series.